Hey guys, this is a video on section 2.1, which is complex numbers. Complex numbers are numbers of the form a plus bi. Okay, so complex numbers are numbers of the form a plus bi where a and b are real numbers, okay, where a and b are real numbers, and I equals the square root of -1. Okay? So complex numbers are numbers of the form a plus bi, where a and b are real numbers, and this I here is actually equal to the square root of -1. And the square root of -1 is actually called the imaginary unit. Okay, so I equals the square root of -1 is the imaginary unit. And the reason it's called imaginary is no real number can be squared to give you -1. So there's no actual real number, so we call it imaginary. In fact, we call it the imaginary unit because there's no real number that would solve this equation. Okay? Alright, so that's a complex number. Numbers of the form a plus bi. And what we're going to be learning about today is how to perform operations on complex numbers. Okay, so let's see an example of this. Okay, example. The instructions here are simplify. Okay, simplify. Write the expression in the form a plus bi. A plus bi. Okay, and that's also called standard form. The name's not that important, but when you write a complex number as a plus bi, that's generally the way you want to write your answer. Alright, so problem number 1, example number 1. Here we're given parentheses 7 minus 8i, end parentheses, plus parentheses 6 plus 6i. Okay, so what we got here is 7 minus 8i plus the quantity 6 plus 6i. And what they want us to do is they actually just want you to add and subtract here by combining like terms. Okay, so we want to write our answer in the form a plus bi, so we're going to have to combine like terms. Combine like terms. So you basically just treat I as if it were any other variable like x, okay, and you combine as usual. So first of all, because we're adding here, we don't even need these parentheses. So I'm going to go ahead and erase these parentheses. Okay, so if I get rid of those, pretending that I is like x, the like terms here are the constants. So the constants are going to be 7 and 6. And then you have the terms involving I. So that's going to be -8i and positive 6i. Okay, and then combining like terms here, we know that 7 plus 6 is actually 13. And then -8i plus 6i gives us -2i. So we get 13 minus 2i. And that's actually all you had to do. That's the entire problem. Because now it's in the form a plus bi, where here a is 13 and b is negative 2. Okay, cool. So we're going to keep going through this section and see some more examples. But when you're just adding, you just combine like terms. That's what we did there. Okay, so for example number 2, we're actually going to be subtracting. So here we have 4 minus the quantity negative 5 plus 7i minus the quantity negative 3 minus I. Okay, so we have positive 4 minus the quantity negative 5 plus 7i minus the quantity negative 3 minus I. And notice there's parentheses here and parentheses there. So this is a lot like the last problem. It's just here we're subtracting instead of adding. So we're going to have an extra step where we distribute the minus to each of these terms. Okay, so here we're going to distribute first, and then we're going to combine like terms. Distribute and combine like terms. Okay, so distributing the negative over each set of parentheses. That's going to switch all the signs. Okay, so we're going to have 4 plus 5. Okay, 4 plus 5 minus 7i. So notice I switched the sign of the negative 5 and the plus 7i to positive 5 and negative 7i. And then we also have to distribute the minus over here. So switching those two minuses, those are both going to be pluses now. So we're going to have plus 3 and plus I. Okay, so we have 4 plus 5 minus 7i plus 3 plus I. So that was the distribute part. And now what we're going to do is we're going to combine like terms. So here the like terms are the constants. So we have 4 plus 5 plus 3. And then we have the terms involving I. So we have negative 7i and positive I. So 4 plus 5 is 9, plus 3 is 12. And then negative 7i plus I is going to give us negative 6i. Because negative 7 plus 1, which is the coefficient here, is negative 6. Okay, so now we've combined like terms, and now we have it in the form a plus bi. Here a is going to be 12, and b is negative 6. And since we got it in that form, we know we're done with the problem. Okay, so 12 minus 6i is our answer. All right, cool. And so far we've done adding, subtracting. Next is multiplying. Okay, so we're going to be multiplying complex numbers. So example number 3. Here we need to multiply 4i times the quantity 4 minus 8i. Okay, so 4i times the quantity 4 minus 8i. So you treat I exactly like it were a variable. So I works just as if it were X or Y or anything else. So what we do here is we distribute the 4i to each term. And you don't just distribute the 4, you distribute the 4 and the I. Okay, so when you distribute to each term, then you're going to get, for the first term, you're going to have 4i times 4. And then for the second term, we're going to have plus 4i times negative 8i. Okay, so 4i times 4 plus 4i times negative 8i. Okay, and then we need to simplify this. And remember, when you're multiplying, just treat I as if it were a variable. Okay, so here for the first term, we know that 4 times 4 is 16i. Okay, so the first term is going to be 16i. And then the second term, we know that 4 times 8 is 32. But there's a minus here, so it's going to be negative 32. So we're going to have minus 32. And then what's I times I? Well, I times I is just I squared. Okay, so we're going to write minus 32 I squared. Now, so far we've just been treating I as a variable and haven't done anything different about it. However, here we're going to have to do one more step. So, important note. I want to give you an important note here. I squared is equal to negative 1. Okay? I squared is equal to negative 1. Now, where did that come from? Well, I squared equals negative 1 because we said that I equals the square root of negative 1. So why does it make sense that I squared equals negative 1? Well, if you look at the original equation that we wrote before, if I equals the square root of negative 1, well, if I square both sides of this equation, I get I squared equals negative 1. Because on the right side, the square root and the square would cancel, and then you're just left with negative 1. And when you're doing a problem, if you ever get I squared, you always replace it with negative 1. So we're actually just going to replace this I squared here with negative 1 instead. Now if you just have I, you leave it as I. But if you ever have I squared, you always replace it with negative 1. Okay, so instead of writing 16i minus 32i squared, we're going to write 16i minus 32 times negative 1. Okay? And because negative 1 times negative 32 is actually positive 32, our answer, if we write it in standard form, is going to be 32 plus 16i. Okay? And notice that I wrote it in the form a plus bi. You always write your a first and then your bi second. Okay, so why didn't this I go away? Well, if you just have an I by itself, it doesn't turn into negative 1. But if you have an I squared, that always becomes negative 1. Okay, so this is actually going to be our answer. 32 plus 16i. Okay. And so that was an example of multiplying using the distributive law. And now I wanted to do another example. I guess we're up to example number 4 now. For example number 4, instead of distributing, we're actually going to be using FOIL. Okay, so we're going to be doing the quantity 5 minus 7i times the quantity 8 minus 3i. Okay, the quantity 5 minus 7i times the quantity 8 minus 3i. Now, again, we're just going to treat I as if it were an x. And here we have 2 terms times 2 terms. So that's actually going to mean we're going to use FOIL here. Okay? So we use FOIL. And hopefully you remember FOIL. But if not, it stands for first, outer, inner, last. So here the first is going to be 5 times 8. So we're going to have 5 times 8 for the first. The outer is going to be 5 times negative 3i. Okay, so plus 5 times negative 3i. And then the inner is going to be negative 7i times 8. Okay, so minus 7i times 8. And then the last is going to be negative 7i times negative 3i. Minus 7i times negative 3i. Okay? And, of course, we have to simplify this. And some of you might be able to do all the FOIL in your head. If you can, you don't have to write it all out like this. I'm just writing it out in case you don't remember FOIL. So, for the first term here, 5 times 8 is 40. For the second term, 5 times negative 3i is negative 15i. For the third term, negative 7i times 8 is negative 56i. And then for the last term, we have 2 minuses, so those 2 minuses cancel out and give you a plus. And then 7 times 3 is 21, and I times I is I squared. Okay, so we actually have 21i squared as our last term. Okay, and then we still have to simplify this a little bit more. So for the middle 2 terms, we can combine them because they're like terms. So negative 15i and negative 56i, we can combine those. And because they're the same sign, we're going to keep the sign and add. So that's going to give us negative 71i. Okay, so for the middle 2 terms, we're going to get negative 71i. Okay, and then for our last term, remember that I squared here is always replaced with negative 1. Okay, so the last term is actually going to be plus 21 times negative 1. Okay, so far we have 40 minus 71i plus 21 times negative 1. And of course, for that last term, 21 times negative 1 is the same as negative 21. Okay, and then combining the first term and the last term, 40 minus 21, we're going to get 19. Okay, so we're going to have 19 minus 71i. And we know we're done because we're in standard form. We're written in the form a plus bi. Here a is 19 and b is negative 71. Okay, so I wanted to do one more example of multiplying before we go on. So example number 5 is next. So for example number 5, we're going to still be multiplying, but this time we actually have an exponent. So this one is the quantity 6 plus 7i, quantity squared. Okay, the quantity 6 plus 7i, quantity squared. Okay, so here what we want to do is, like I said, we want to multiply. Now, how do you multiply? And can you just distribute the square? Turns out you can't distribute the square because it has more than one term. but you can rewrite this expression as 6 plus 7i times itself. Okay, so 6 plus 7i times 6 plus 7i. Alright, and then now that it's written like this, it's just like the last problem, where we have two terms times two terms, so a binomial times a binomial. And to multiply that out, once again, you're going to use FOIL. Okay, so it's actually just the same as the last problem. It's just a question of dealing with the square. But once you realize that the square can't be distributed, you just rewrite it as 6 plus 7i times itself. And then you use FOIL. Okay, so using FOIL here, the first is going to be 6 times 6 is 36. The outer is going to be 6 times 7i, which is 42i. So we have plus 42i. The inner is going to be 7i times 6, which is also plus 42i. And then the last is going to be 7i times 7i. So that's going to give us 49i squared. Because 7 times 7 is 49, and I times I is I squared. Okay? So what we have is 36 plus 42i plus 42i plus 49i squared. And we want to actually simplify this. Okay? And remember, you always replace I squared with negative 1. So first off, I'm going to do that. So this I squared is just going to be negative 1. So what we've got here is 36 plus 42i plus 42i minus 49. Okay, and then we can combine like terms. So here the like terms are the 36 and the negative 49, and then the 42i and the other 42i. So combining like terms here, we have 36 minus 49. Well, those are opposite signs, so we're going to be subtracting. And we know that 49 minus 36 is 13. But since the larger number was negative, it's going to be negative 13. So we have negative 13, and then 42i plus 42i is going to give us 84i. So we have negative 13 plus 84i. Okay? And notice we've got it in standard form, a plus bi, so we're done. So this is going to be our answer. Negative 13 plus 84i. Okay, so we're working through the operations with complex numbers. So far we've done adding, subtracting, and multiplying. Now the last operation is obviously dividing. So let's see an example of dividing complex numbers. Actually, we'll probably do a couple of them. So we just did example number 5. So now we're moving on to example number 6. Okay? Example number 6, we're actually going to be dividing. So we're going to have a fraction here. This one is 3 over 6 minus I. 3 over 6 minus I. So we're clearly dividing here since we have the division bar. And the trick here is knowing how to divide a complex number. So let me talk about how you divide complex numbers. So the basic idea is you multiply the top and the bottom. So you multiply the numerator and denominator by the conjugate, okay, by the conjugate That's a big word, I know, but we'll talk about what that means in just a second. So you multiply the numerator and the denominator by the conjugate of the denominator. Okay. So, first of all, we need to talk about what this word conjugate means. So the conjugate is actually just means that you switch the sign of the second term. Okay, so for the conjugate, you switch the sign of the second term. Okay? So what we're going to be doing is we're going to be multiplying the top and the bottom by the conjugate of the bottom. So going back up here, we're going to multiply the top and the bottom by the conjugate of 6 minus I. And how do you find the conjugate? You switch the sign of the second term only. Okay? So what's the conjugate of 6 minus I going to be? Well, it's the exact same expression. It's still 6 and I, but you switch the sign of the second term. Okay? So here, we're actually going to have the conjugate, instead of being 6 minus I, is going to be 6 plus I. Okay, so I'm going to multiply the top and the bottom by 6 plus I. 6 plus I. Okay? And then we actually have to simplify this a little bit. So on the top, we have to distribute the 3. And on the bottom, we have to use FOIL. Okay, so we have to multiply on the top and on the bottom. So on the top, we're going to get 3 times 6 is 18. And then 3 times I is 3I, so we have 18 plus 3I on the top. And then on the bottom, using FOIL, we're going to get 6 times 6 is 36. That's the first. The outer is going to be positive 6I. The inner is going to be negative 6I. And then the last is actually going to be negative I times I, which is negative I squared. So for our last term, we're going to have negative I squared. Okay? So you should actually have 18 plus 3I on the top, because we distributed the 3 to each term. And then on the bottom, using FOIL, you should have 36 plus 6I minus 6I minus I squared. And remember that that I squared is just the same as negative 1. So this is just negative 1. Okay. So on the bottom there, simplifying all this, we've got 36 plus 6I minus 6I. Well, those just cancel out. Those are like terms. And then we have minus negative 1, which is plus 1. So on the bottom, we just have 36 plus 1. And on the top, we have 18 plus 3I. Okay, and we can't really simplify the top, but we can simplify the bottom. Okay, so on the bottom, 36 plus 1 is 37. So we get 18 plus 3I all over 37. Okay? And the thing is, the way we have it written now, it's not written in standard form. Remember, you have to always write your answer in the form A plus BI. So to finish writing it as A plus BI, we have to distribute the 37 to each denominator. So that's what we're going to do as our last step. So we're going to split it up into two fractions. So we have 18 over 37 plus 3 over 37. And then I'm going to go ahead and bring that I for the second term in front of it. So here you can see we've written in the form a plus bi, where a is 18 over 37 and b is 3 over 37. Okay, and that's going to be our answer. Okay, and in your homework you're going to get to practice some harder ones where you divide, but the top and the bottom both are in the form a plus bi. But remember, you're basically just always going to be multiplying the top and the bottom by the conjugate. Okay? And remember, the conjugate just means you switch the sign of the second term. Okay, so I should probably do one more example of dividing because dividing is a little bit harder. Okay, so that was example number 6 that we just did. So now we're going to go ahead and do example number 7. A lot of examples today. Okay, so example number 7 is 2 plus 6i all over 3 plus 6i. 2 plus 6i all over 3 plus 6i. Alright, so once again, because there's a division bar, they want us to divide. And what's the conjugate going to be here? Well, the conjugate of 3 plus 6i means that we just switch the sign of the second term. So instead of 3 plus 6i, we're going to have 3 minus 6i. Okay, so here the conjugate is 3 minus 6i. Okay, and what do we do with the conjugate? Well, we multiply it to the numerator and the denominator. So we found the conjugate of the denominator. Now we multiply the top and the bottom by the conjugate. So we multiply the top and the bottom by 3 minus 6i. Okay, and then this one's going to be a little bit harder than the last problem, because here we're going to have to use FOIL on the top and the bottom. Since it's 2 terms times 2 terms, we're going to use FOIL everywhere. So we have our work cut out for us. So on the top, using FOIL, we have the first is 2 times 3 is 6. Okay, so we have 6. And then the outer is going to be 2 times negative 6i, which is negative 12i. The inner is going to be 6i times 3, which is 18i. And then the last is going to be 6i times negative 6i, which is going to give us negative 36i squared. Negative 36i squared. Okay? And with all of that, we've got the top. And then on the bottom, we're going to be doing the same thing. We're also going to be using FOIL down here. So on the bottom, 3 times 3 is 9 for the first. The outer is going to be 3 times negative 6i, which is negative 18i. The inner is going to be 6i times 3, which is positive 18i. And then the last is actually going to be 6i times negative 6i, which is negative 36i squared. Okay, so we have negative 36i squared. Okay, now that we've done all that, now we can actually simplify everything. So on the bottom, combining like terms, the negative 18i and the positive 18i just cancel out because they're opposite signs. And then with our I squareds here, both of those I squared become negative 1. Okay, so those both become -1. So what do we got here? We've got 6 minus 12i plus 18i plus 36, because the minuses cancel. And then on the bottom, we have 9 plus 36. Okay, so on the bottom, -36 times -1 is positive 36. So all we have to do now is combine like terms. So on the top, we can combine -12i and positive 18i. And then we can also combine 6 and 36 on the top. And then on the bottom, we can also combine like terms. So on the bottom, we have 9 plus 36. Okay? So combining all that stuff, what do we get? Well, on the top, 6 plus 36 is 42. And then -12i plus 18i gives us positive 6i. So on the top, we actually have 42 plus 6i. And then on the bottom, 9 plus 36 is actually 45. So we have 45 in the denominator. Okay, and then just like the last problem, they do want you to simplify this a little bit. So you're going to distribute the 45 to each denominator, which means you're going to split it up into 2 fractions. Okay, so we're going to have 42 over 45 plus 6 over 45 times I. Okay, 42 over 45 plus 6 over 45 times I. And then you can simplify these fractions a little bit. So for example, this first fraction, we can divide the top and the bottom by 3. So if I divide the top and the bottom by 3, I'm going to get 42 divided by 3 is 14. And then 45 divided by 3 is 15. So we have 14 over 15. And then for the second fraction here, we can also divide the top and the bottom by 3. Divide the top and the bottom by 3. Okay, so for the second fraction, we have 6 divided by 3 is 2. And 45 divided by 3 is 15. So you should have 2 over 15 times I. So our answer is going to be 14 over 15 plus 2 over 15 times I. Okay? And that completes all of the operations with complex numbers: addition, subtraction, multiplication, and division.